Hey guys, welcome back to my channel. As you all have seen, I've rebranded my little Unreal School channel, and the reason for that is that I actually wanted to create more diverse content here with tutorials that are not only limited to Unreal Engine 4, but I've actually started using UE4 again. As some of you might have noticed, I've been streaming a lot recently. I've done the GMTK Game Jam, and I've also done a lot of random streams where I was dabbling a bit around with UE4.25. And yesterday I actually streamed about my progress on a little game that I'm currently working on. It's very early in the progress. It's a little RTS/roguelike mix that I want to make. And if you would like to see me live while I do this, you can actually visit me on my Twitch channel, twitch.tv/braincheck, to see the progress. Now, while I was making the little game, I actually had to set up the camera controls. And I thought that might be a good opportunity to make a little tutorial on how to do a very simple RTS camera in Unreal Engine 4. Enjoy. Alright, so we are here in the top-down template. I've just created a new project using the top-down blueprint sample, and I've actually made some changes. So this is the normal character. I've renamed it to RTS unit, but that's not important. There's like a top-down character. And in the original version of that blueprint, there's a camera boom and a camera and stuff existing on that blueprint. We need to remove that because we will be removing the camera to a new pawn, which we are going to create now. I also made this game mode. There's a game mode in the sample which you can use. So no worries about this. It's just to set up the default pawn. So what we're going to do is create a new blueprint class, and we're actually going to derive from pawn, and we call this tutorial RTS spectator pawn. It's just how I call it. It's not going to be, it's not a spectator pawn. There's actually a class for it, but that's just a fitting name. So this pawn is first of all going to be set up as the default pawn class. So tutorial RTS spectator pawn, and then if we now hit play, you can see nothing happens, and that's expected because the default pawn doesn't really do anything. Now what we need to do is set up some input bindings, which we are going to need for this tutorial. So that's actually the wrong window. In project settings, edit project settings, under input, you can see that I've already set up some action mappings, which are not important for our camera. All we care about are these axis mappings. Now I've renamed the move forward and move right to move camera forward and move camera right, but they're still bound to W, A, S, and D. And there's also this zoom stuff, which will allow us to zoom the camera in and out. Now for the zoom, it's important to use this mouse wheel axis and not the up and down. Apparently you can't really use up and down when you have an axis binding. I've had to learn that the hard way. So yeah, just use mouse wheel axis. It will still generate values between 1 and -1. So back at our RTS pawn, we actually need to add some components. First of all, we are going to add a floating pawn movement. This is the component that will actually allow us to move the camera around. So let's just keep that name. Then we are going to add a boom arm. A spring arm. Oh, sorry. I was a little bit confused because it's called boom and on the default. A little brain fart there. And then we need a camera, which is child to the boom, the spring arm. So as you can see, we have now this setup. We're going to edit this a bit. Let's go to our camera spring arm and set the target length to 900. And then we need to actually rotate this a bit. I think 60 degrees is about right. And now if we hit play, you can see our camera is rotating. All right. Now let's actually go to our event graph and try to implement the actual movement. Sorry for the stuttering. Seems to be a little brain farty today. So let's go to a sequence. Now we're going to implement two types of camera movement. The first is going to be using keyword input, WASD, and the other is going to be using the mouse when you scroll near the edge of the screen. So the first one is actually super easy. We're just going to call it movement input. Now the good thing about this is that we don't really need to reference our component. The add movement input will automatically forward the input towards any movement component that is on the pawn. Let's split this struct, and then let's call get axis camera forward, get axis camera right. Let's hook this up to the X and the Y. And now if we hit play and press A, you can see that we are moving. But for some reason it seems to be inverted. Which might be an issue with my input settings. So let's have a look. So W is left, so this should be... No, W is forward. That's weird. Let's just change these. And now you can see we can actually move the camera, but you can also see that there's still some glitchiness happening. And that's a problem with our camera boom. Forgot to change something. There is a collision, the collision test flag. If we can get rid of this, it will no longer collide with any objects. And as you can see, there's also no gravity or something. We are just floating on that plane, which is basically what you want in an RTS style camera. Now I've called this RTS style, but you could also use this for like a city building game or something like that. It's just a free floating camera that's attached to its own pawn. Now, the next thing we're going to do is that we are going to do the mouse scrolling when you hit the edge of the screen. And for that, we are going to add a little function. So let's go to our functions, hit add, and we are calling this mouse move on axis. Now, this function is just a little bit for convenience sake, because otherwise you would have to duplicate some code and it's never nice. So let's just wrap this in a function. So what we are going to need is two float parameters and a vector parameter. The first float is going to be called position on axis. Now we're going to call this this method twice. One once for the X and once for the Y axis. And this position on axis is the position of the mouse cursor on the given axis. The second parameter is called axis length. Now this is the total length of the axis. So let's say if this is our screen, right? This is the x-axis, and the length of the axis would be the width of the screen. So that's what we're going to input here. And we use this value to determine how far along we are on the screen, so we know how close we are to the edge. And this parameter is the axis itself. So this is just for moving the camera. So now let's do a little bit of math. We're going to take the axis length and subtract our position on the axis. Then we're going to take the axis length and subtract 1 from it. We're going to check if this is less than a value that we can determine ourselves. And we can check if this is greater than this. So let me explain real quick what this does. The axis length is the overall length of our axis, and we subtract the position of the axis. So let's say our axis is 1000 units wide, and we are here at this area on the screen, which is like coordinate 950. So we would get 50 when we subtract it, which means we are 50 units away from the screen. Now this check actually is used to determine whether or not we should move the screen. Now this is just a 1 pixel margin, which pretty much means we need to touch the edge of the screen, which is what I found a very good behavior. It's a very common behavior in RTS games. The same applies here. So for this value, we are checking whether the position is actually on the left side of the axis. See, if we have an axis that is 1000 units long and we subtract 1 of that, the position would actually have to be 1000 in order for that to work. So now all we need to do is actually add 2 branches. We hook up the first condition to this, the second one to this. Now if this is true, we add a movement input, and the movement input will be in the world direction that we are providing as a parameter. Otherwise, also make sure this is -1, so we move on the negative direction of the axis. Otherwise, if this is true, we should do this. So now all we have to do in our event graph is to go here and get our mouse position. And our viewport size. And now we need to move mouse on axis, and like so. Let's split the struct and split. Let me see. Oh, I'm sorry, I accidentally clicked that and didn't see it. Let me get rid of that. So Let's hook this up here. This up here. This goes in here. And there. And now all we need to do is to provide the axis in which we are moving. And now, if we didn't, I actually can't see the mouse cursor. Let me see if this works here. So if you move up here, you can see it moves up. If we go to the left, you can see it goes there. Same for the other directions. All right. Now the last thing we are going to do in this little tutorial is we are going to handle the zoom. So let's get our input axis zoom. All right. So we shouldn't be able to zoom infinitely, and also we can't zoom super close, like infinitely in the small direction. So what we're actually going to do is we're going to define two variables. One is the min camera distance. The other is the max camera distance. So let's see. Let's compile. For min camera distance, we're just going to set it to 900, which is like our default distance. And for max camera distance, we're going to use 1800. All right. Let's get our camera boom. And now to zoom, actually all we need to do is to call set target arm length. Now all we need to do is to find out how we get this. All right. We're going to get our world delta seconds. So we multiply, we frame rate independent. Sorry, I'm really stuck today. Also, we need another variable which we are calling zoom speed, and this is going to be quite the high value. My test I've used 9000, so let's just use that. So when I tested this first, the zoom was actually inverted. So when I got my mouse wheel rolling up, it zoomed out, vice versa. Now, if you like that or not is totally up to you. I didn't, so I inverted the input, which came from the axis, so it would zoom in the right direction. So that's why I multiply this by -1. Then I multiply this value again. I get the zoom speed, multiply it with delta seconds, so we are frame rate independent. We put it here, so now it will change direction. And now all we have to do is to clamp this value, so we never get below our min camera distance or above our max camera distance. Hook it up here, and now it should work. Okay, I appear to have forgotten an important step. Now, in order to actually change the value, we need to get target arm length, and then we need to add this value on top of it, and that is what we're going to be inserting here. And now if I disable this breakpoint, it actually zooms, and as you can see, we can go further in than this or further out than that. You can tweak this value however you like, and that pretty much concludes our little tutorial. Now, I'm already seeing you guys asking me how you would rotate the camera, and you can see that as a little bit of homework. Now, all you pretty much need to do is rotate the pawn. That's not super hard to do. But yeah, that's pretty much all there is to it. And that pretty much concludes our little tutorial. Yeah, and that's pretty much it. It's a very simple but robust solution to a very common problem. I hope it was helpful. If it was, make sure to leave a thumbs up on the video. Also remember to subscribe to the channel. Leave a comment if you have any questions. Ring the bell. Look at my Twitch chat. I'll be streaming more this week. And I'll see you in the next video. Bye bye.